Hi everyone. Hi everyone. My name is Andre Vicente Liz. I'm a PhD student at Civio in Portugal, also working at the Zoological Research Museum of Bonn. And today I'm going to present a part of my PhD work, which consists on a preliminary overview of the genetic patterns of vertebrates across the Sahara Desert, with the aim of contributing to biodiversity conservation in this region. And I'm doing this through an interspecific approach, considering that interspecific genetic diversity it's one of the three main components of biodiversity. And however, despite its relevance for conservation of survival of species and well-functioning of ecosystems, it has been progressively eroded due to the ongoing mass extinction for several decades. And despite this, it has received little attention in terms of conservation until very recent times. For instance, the last framework of the Conventional Biological Diversity Action Plan for the next decade already includes the conservation of genetic diversity as an important component of this action plan, right? Um, Beyond this brief introduction of genetic diversity, here I jump to the study region, which is the Sahara Desert and the neighboring arid Sahel in North Africa, which together constitute the largest warm desert in the world. However, although we are all familiarized with the Sahara as a massive arid barrier, it has not always been this kind of ecosystem. In fact, since the onset of the desert conditions around 7 million years ago, the region has shifted drastically between an hyper-arid desert, as we know it nowadays, and a rather savanna-like scenario where the sand dunes were replaced by overall by grasslands, grass fields, and also aquatic and relatively well moisturized ecosystems, right? That were also interconnected. This variability in terms of paleoclimate and land cover throughout the Pleistocene, together with the heterogeneity of the region in terms of topography and climate, makes this a very interesting system to understand the patterns of evolution and range shifts of desert species, right? It has been proposed that the species that are more adapted or that inhabit the sand dunes, the more hyper-arid habitat of the Sahara Desert, likely underwent isolation during these phases of green Sahara, savanna-like Sahara, because the sand dunes were actually restricted to a very small patches, right? So this dynamics of isolation and then further and then later expansion and reconnectivity of populations when the desert became hyper-arid again had probably a very important impact on the diversification of the desert biodiversity. Here I present the opposite case, which is the case of the mesic group, the organisms, vertebrates that were mostly associated to relatively mild habitats. They were not so adapted to, not so tolerant to hyper-arid conditions, right? So instead of undergoing isolation in the sand dunes, they likely were fragmented in these little patches of relatively mild ecosystems during hyper-arid desert phases, as it is nowadays. And these areas are mostly the arid mountains that are scattered across Central Sahara, and also the fringes in the north, southern foothills of the Atlas, and then the coasts in the east and west, and the Sahel in the south. As I said, these dynamics of range fragmentation, reconnectivity, etc., likely drove the evolution of desert species because of this refugia or long-term persistence in refugia for each functional group, right? This long-term persistence and the extinction of populations beyond or outside these areas makes that this refugia should keep an imprint of higher degree of differentiation in terms of genetics, as they may constitute hotspots of genetic diversity, right, in relation with areas of recent expansion. However, it has never been assessed at a multi-taxa level where these hotspots of refugia and genetic diversity are located for either of these two functional groups, the Xeric species. Do they persist in these pockets of sand dunes that persisted throughout the climatic fluctuations? And again, same for the mesic species. Did populations persisted in pockets of mild climate like mountains? Well, this is what we do in this work at a multi-taxa level. We use representatives of desert reptile and mammal species that are relative endemic or almost endemic to the North Africa. We categorize or we classify species based on the on the traits of their distribution ranges, the aridity index, the levels of aridity index, into Xeric and mesic functional groups. And in total, to have in total a data set of 14 families, 34 species of mammals and reptiles, and over 3,600 georeferenced samples for which the cytochrome B mitochondrial marker was available, right? So this is a portion of the relatively fast evolving region of the mitochondrial genome, which is commonly used in phylogeographic studies. We then calculated the nucleotide diversity for the haplotype, for the cytochrome B haplotypes of within each species, in order to have sign a proxy of genetic distinctiveness, haplotype distinctiveness for each sample within each species. We interpolated these values across the Sahara-Sahel. Down here you will see the workflow of how we did these interpolations and subsequent processes. We cropped these interpolations to the species polygons, sometimes only using the IUCN polygons. Other times we had to add buffers for samples that were outside the polygons of the IUCN, especially for mammals. We converted the interpolated values of nucleotide diversity into a binary projection to keep only those areas with the highest nucleotide diversity, which were considered the hotspots. We use set threshold areas with over 70% of or the highest 30% among all values of nucleotide diversity, right? We combined these maps for each functional group. So basically we put together all the hotspot genetic hotspot maps for both Xeric and then for the mesic species. And we weighted these maps by also maps of species richness. So after doing this for both the Xeric and the mesic functional group, we obtained a map of areas of higher genetic distinctiveness across the desert. And we can easily see that in the case of the Xeric group, there is a pattern of higher genetic differentiation in the sand-dune fields. I said it's easily, but here I didn't plot together the ergs or the mountains in the other case. So it's obviously not so easy, but well, trust me here, these areas in the north of the Sahara, the ones with the thicker line, they represent mostly the ergs of northern Algeria, northern Tunisia, great western and eastern ergs, also the Libyan desert in the northeastern Sahara. And beyond these two well highlighted areas, also other ergs in the more inland areas, such as the northern Mauritania, northern Mali, region which is almost hell on earth because the climate is really extreme in this region, also appeared as highlighted. In the case of the mesic group, mountains across Central Sahara were highlighted as diversification hotspots, as well as the southern foothills of the Atlas in the northwestern Sahara. Beyond mountains, desert fringes, both the coast, the Red Sea, Atlantic coast, Sahel in the south in Niger, and the areas of around the Atlas in northern Sahara were also highlighted. Now, if we want to understand what are the implications of these patterns of genetic distinctiveness in terms of conservation, well, we basically plot these two maps for the Xeric and mesic group together with the current network of protected areas. And we observe that in the case of the Xeric species that are all traditionally they are receiving little conservation and research attention because they are or people believe that these habitats are relatively uniform and bare of life. The hotspots of Xeric diversity in the arcs, they are actually not integrated in most of the conservation strategies. Neither the Algerian ergs or most of the Libyan desert are integrated in any conservation reserve, for instance. Case of the mesic group, it's relatively different. It seems like at least the mountains in Central Sahara, as Tassili, Hogar, especially Tassili in Algeria, the Air, the mountains in Gilf Kebir, Egypt, or even Enedi in Chad, they appear to be integrated in this in networks of protected areas, right? However, we have a big example of an area that was highlighted as an important diversification hotspots, which is not included as in these areas. The other the Sifogas in northern Mali, which is being subjected to or has been well subjected to armed conflicts for several decades, right? So it's really it's a challenge to implement any kind of conservation program in this area, or even monitor populations or sample or design reserves here, right? Going a bit further or expanding a bit further this issue of the armed conflicts in the Sahara, this is a really dramatic issue that first affects human population in this region of the world, but also it has impacts in terms of biodiversity conservation, because there is problems are to basically implement any kind of conservation program in the region because of well, challenging conditions to do anything there. At the same time, there is a zero control on the depletion of the megafauna, of course, in this area, right? So most of the polygons that are highlighted now in the maps of both genetic hotspots show that areas that are important for interspecific diversity, they are overlapping with these areas of conflict, right? So this makes really complicated to protect these important areas for biodiversity. And beyond this thing that we know that these areas are important, but it's challenging to conserve them, there are also other areas which are subjected to massive knowledge gaps, where we basically have almost no samples, so there are no samples available to actually understand if they are or not hotspots for biodiversity, for the genetic component of biodiversity, right? But we expect them to be hotspots as the mountains in northern Chad, for instance, because they are also very similar to the other hotspots that we find in terms of environment across the Sahara. And to finish, what are the prospects for the future? Which are the pressures that will affect the mesic and Xeric hotspots of genetic diversity? Well, we see that in the case of the Xeric group, most of these ergs or the erg lowlands will be highly impacted by global warming, while in the case of the mesic group, the hotspots will mostly be, or let's say the largest pressure may be the human linked impacts, right? Like sub-Saharan Africa, for instance, is expected to undergo the largest growth in terms of human population in the next decades. The population settlements along the Sahel will likely increase, as well as human footprint, and this will be a really important challenge to maintain to conserve biodiversity in the region. So just to wrap up, here I presented patterns of interspecific genetic diversity across the Sahara-Sahel. We see that the location of the hotspots depend on the species habitat requirements. They are different for Xeric and mesic functional groups. Current network of protected areas overlooks the unique interspecific diversity of Xeric species. Of the ongoing sociopolitical instability and armed conflict in the region are hindering conservation actions, as well as maintain biodiversity shortfalls in several areas of Central Sahara. And then for the next decades, different mitigation strategies are needed to preserve hotspots of Xeric and mesic genetic diversity. So that's all. I just want to thank my group in Porto, who has been carrying out work in the Sahara in collaboration with local partners for almost 20 years. And to everybody that contribute to this work, my supervisors, Denis Reder, José Carlos Brito, Duarte Gonçalves, our collaborators, and all the funding institutions. Thank you.